Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 4 in the Business Logic Vulnerabilities module titled Flawed Enforcement of Business Rules. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portsfigure.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy, select all labs, and then do a search on Business Logic Vulnerabilities and select lab number 4 titled Flawed Enforcement of Business Rules. Alright, let's get started. This lab has a logic flaw in its purchasing workflow. To solve the lab, exploit this flaw to buy a lightweight leather jacket. You can log into your own account using the following credentials. Alright, so the target goal over here is to exploit the logic flaw to buy this item over here for less than the intended price. And the way we're going to do that is first log in as a user and then attempt to identify the vulnerability. Alright, let's access the lab. Now notice over here, this is the built-in browser in Burp, and so all my requests are already passing through my proxy. Alright, the first thing we're going to do is go to my account and then log in with the credentials that we were given. So the password was Peter, hit login. And then you could see over here the store credit that we have is $100. We're going to click on home and look for the item that we need to purchase. So that would be this item right over here. So the lightweight leather jacket, which costs $1,337. And we clearly can't afford that because we only have $100. So let's click on view details, go down, add to cart, and send that request to a repeater. And then from there, go to our cart. And notice over here, we've got a new functionality that allows us to add a coupon. And you could see over here, you get a coupon for being a new customer and it knocks off $5 or maybe 5% off of the cost of the jacket. So let's assume that we tried everything that we tried in the previous couple of labs and it didn't work. And so now we're going to test the coupon functionality to see if there's any vulnerabilities in that functionality. So let's add a coupon over here, click apply. And we're going to send that request to repeater as well so that we could test it. And you could see over here, it knocks off $5. And then I'm going to place order and send that request to repeater as well. All right. So it says over here, not enough store credit for this purchase because it costs $1,332 after the discount and we only have $100. So let's go to repeater and see the requests that were made by the application. So when we clicked on place order, it performed this request over here. And if we look at the parameters that this request takes, it just takes in a CSRF token. So this is definitely not the request that we want to exploit because it doesn't take in any client-side parameters that could potentially change the price of the item. So let's move on to the next request. The next one is when we added a coupon to the cart. So over here, it knocked off $5 for the item. And so what I'm going to do is I'm going to check the parameters that it takes in. You could see over here, there's a CSRF token, so that's standard. And then the next parameter that it takes is the value of the coupon. A really classic case that I've seen in real-world applications is that the application doesn't check if you've applied the coupon before, and so it allows you to apply it an infinite number of times. So let's see if that's the vulnerability in this application. So you get a 302. Let's reload our page. And over here it says the coupon is already applied. So it does not allow us to apply the coupon more than one time. Now, you could always guess any other coupons. So if there's no throttling mechanism over here, you could send a million requests to the application within a few minutes and then try to see if there's any other coupons that are not discovered in the application. But this is under the Business Logic Vulnerabilities module, and so it should be a business logic flaw that we need to exploit. And so to do that, we need to see if there's any other part of the application that could potentially allow us to exploit that business logic flaw. So let's go to home and then go down to see if there's any new functionality. So there is a functionality that allows us to sign up to their newsletter. So let's just test it out. Say test.test.ca and click on sign up. And over here, it says use the coupon sign up 30 at checkout. So because we signed up, it gave us a coupon that maybe knocks off $30 off of our account. So let's go to the card over here. And then let's add the coupon to see if we could use it. Hit apply. And we can, and it looks like it knocked off $401, so maybe 30% of the cost. It looks like it's a little bit more than 30% of the cost of the price. Or maybe it is 30% and I can't do math. But the idea is that it allows you to add as many coupons as you want. Now this is still $930.90, and so we still can't afford it. So let's see if we could add this coupon multiple times. Hit send, and then reload the page. And it gives you the same error, which is coupon is already applied. So the next thing that I'm going to try is try and add this coupon. If the backend code only verifies the last coupon that you added, then maybe we can get away with alternating the coupons and then reducing the price to less than $100. So let's try that over here and see if it works. Let's reload the page. And here we go. We could apply the coupon again as long as it's not consecutively. So when we tried New Cust 5, and then we tried New Cust 5 again, right after the first one, we weren't allowed to do it, but because we used another coupon, the application seems to only check the last coupon, and if it's not equal to the last coupon, then it allows us to apply it again. And so let's do that for the sign up 30. Hit send, reload the page, and it allowed us to apply it, so we're at 524. Let's hit send again, reload the page. Okay, we're getting there. Hit send, reload the page, and we're at 118, so we're almost there. Hit send, and that's not going to work because we're already at sign up 30, so it needs to be at New Cust 5. Hit send, reload the page. We're at 113, so we only need one more request with sign up 30, and it should work. And here we go. So the total is $0.00. Let's see if the application allows us to perform this request. Click on place order. And here we go. It says, congratulations, you solved the lab. All right, so we successfully completed the exercise by exploiting the vulnerability manually. Now let's script it in Python. All right. The first thing we're going to do is import all the libraries that we need. So the requests library, the sys library, the URL lib3 library, and then from BS4, import beautiful soup, and then import the RE library as well. Next, we're going to disable insecure request warnings. So disable warnings, URL lib3 dot exceptions dot insecure request warning. And then we're going to set our proxies configuration. So proxies is equal to HTTP 127.0.0.1 port 8080. So this tells the script to send all HTTP traffic to where burp is configured. And then we're going to do the same for HTTPS traffic. Next, we're going to create our main method. So if name is equal to main, then call the main method, and then we're going to say def main if the length of the command line argument, so sys.argv, is not equal to 2, so if the user runs the program incorrectly, then we're going to print the usage instructions and the example instructions. And we'll start off with the usage instructions, so the name of the program and the URL. And we take the name of the program from the command line argument. So sys.argv0. And then we also print the example instructions. So example %s and then an example URL, so www.example.com. And again, the name of the program is from the command line argument. And then we exit the program. Okay, this looks good. Now let's assume the user does run it correctly. In that case, we initialize our sessions object. And then we create a variable called URL. And we take that from the command line argument. And then we call a function called byItem that takes in the session object and the URL. All right, this looks good. Now byItem is a custom function, and so we'll create it right now. So def byItem takes in the session object and the URL. The first thing that we're going to do is log in using our user account that we were given. And so if we go to proxy, and let's move this right over here, and we look for the login request. It's this one right over here. If we go down, you could see it takes in 3 parameters, the CSRF token, the username, and the password. The username and password we were given, but the CSRF token we need to extract. And we'll be extracting it from the request that was made before the post request, which is the get request to the login page. So if we look over here, it's extracted from this response. And so to extract it, the first thing we're going to do is we're going to say retrieve the CSRF token, and then we'll say login URL. So the URL to login is the URL of the main application plus the endpoint / login. And then for the CSRF token, we're going to create a variable called CSRF token. And then we're going to extract it by using the function get CSRF token that takes in the session object and the login URL. And that's a custom function that we'll create ourselves. So before we create it, we're going to say rest of code here. And then we'll create the function. All right, so def get CSRF token. It takes in the session object and the URL. We'll perform the request that has the CSRF token. So s.get URL verify is equal to false because I don't want to verify TLS certificates, and proxies is equal to proxies because I want my request to be sent in burp. And then we're going to use beautiful soup to parse the response, which is r.text, and we're going to set the parser to html.parser. And we're going to create a variable called CSRF and extract the CSRF token from the response. So soup.find, and we need to find it in the response. And so if we look over here, it's in an input element that has a name attribute that is equal to CSRF, and the value that we want to extract is in the value attribute. And so we're going to say find the input element that has a name attribute, and the name attribute has to be equal to CSRF, and I want the contents of the value attribute. And just to make that consistent, let's make that all single quotes. All right, this looks good. And then I'm going to return the CSRF token. So this extracts the CSRF token and then saves it in the variable CSRF token. And so now we could log in as the user that we were given. To do that, we're going to print first logging in as the user. And then we're going to save all the parameters that are taken in the login request in a variable called data login. So if we go to our login request, which is a post method to the endpoint /login, and it takes in these three parameters, so CSRF, username, and password. So we'll start off with CSRF. That's equal to the CSRF token that we just extracted. And then we've got username, which is equal to the username of the user that we were given, and password is equal to the password of the user that we were given. And then we perform the request. So r is equal to s.post because it is a post method. It takes in the login URL and then the parameters. So data is equal to data login. And then verify is equal to false because I don't want to verify TLS certificates, and proxies is equal to proxies. And I'm going to save the response in a variable called res. And then from there, I'm going to verify that I properly logged in. So I'm going to check if the string logout is in the response. If it is, then I'll print successfully logged in as the user. Otherwise, I'm going to print could not log in as the user. All right, so we logged in as the user account. Now the next step is to add the jacket to our cart. So let's say add item to cart. And to do that, we need the request that was responsible for adding an item, which was this one right over here. So it's to the /cart endpoint. So let's say cart URL is equal to URL plus /cart. And let's scroll up. And then from there, it took in a few parameters. So let's say data cart is equal to the values that it takes in. So if we go down right over here, it took in the product ID, the redirect, and then the quantity. So let's add them right over here. So product ID is equal to 1, and then redirect is equal to product. And then we also had quantity is equal to 1. This looks good. And then we just perform the request. So r is equal to s.post. It takes in the cart URL. And then data is equal to data dash cart or underscore cart. And then verify is equal to false because I don't want to verify TLS certificates. And proxies is equal to proxies. And this adds the item to my cart. So the next step is to add the coupons. Now, in order to add the coupons, I need a way to alternate between the $5 coupon and then the 30% off coupon. And so to do that, I'm going to create a for loop that does that for me. And so if we see how many times we perform this request, we've got 1, 2, 3, 4, 5, 6, 7, and 8. And so we performed the adding coupon request 8 times. So I'm going to say first coupon URL is equal to URL plus the URL to add a coupon. And so if we go to burp right over here, it should be in this request. So it's /cart /coupon. And then I'm going to create a for loop that does this for me. So I'm going to say for I in the range 9. So it'll start off from 1 and end at 8. The way I'm going to differentiate between adding the $5 coupon and the 30% off coupon is based on whether the integer I is odd or even. So let's say if it's odd, then you add the $5 coupon. If it's even, then you add the 30% off coupon. And the way I'm going to do that is using the modulus operator. So if I modulus 2 is equal to 0, that means it's even. Let's say we apply the $5 coupon, and if it's odd, we apply the $30 coupon. So to do that, it's going to be a really similar code. So I'm just going to copy it from over here and put it in here. Okay, so the URL is the coupon URL, which is already available for us over here. Next, we need to see the parameters that it takes in. So it takes in a CSRF token and the coupon. Now for the CSRF token, we need to extract it. So I'm going to say CSRF token is equal to get CSRF token, the function that we just created. I'm going to give it the session object, and then the URL to cart URL, and it'll extract the token for me and save it in a variable called CSRF token. And then I'm going to change this to data, new cost 5, and that's going to contain the CSRF token, which is CSRF, and that's equal to the variable CSRF token that we just extracted. And then it also takes in the coupon variable, so let's add that right over here. And we're going to equal that to new cost 5. And let's remove the rest. All right, this looks good. And then we perform the post request to the cart URL. So if we go over here, it should actually be the coupon URL. So coupon URL data is equal to data new cost 5, and then verify is equal to files, and proxies is equal to proxies. So if it's even, it applies this coupon. Now if it's odd, it'll apply the other coupon. So let's copy this and just paste it over here. So we'll call this sign up 30, and then it'll be the sign up 30 coupon. And then change this as well to sign up 30, and this looks good. All right, so essentially what happens over here, I will start off at 1, and then it'll apply the sign up 30 coupon, and then it'll move to 2, it'll apply the new cost 5 coupon, and then 3, it'll apply the sign up 30 coupon, and then 4, and apply the new cost 5 coupon, and so on until it reaches the value 8. And so this way we're alternating between the two coupons. Now the last thing to do is check if we solve the lab. And to do that, we're going to say if congratulations. So the message that we get when we solve the lab is in the response of the request after we're done with the for loop. Then we'll print successfully exploited the business logic vulnerability. Otherwise, we'll print could not exploit the business logic vulnerability. And I spelled that incorrectly. And then we'll exit the program because the exploit failed. All right, this looks good. Let's save it. And hopefully we don't have any errors in our script. It's likely the application timed out, and so we'll just open a new instance of it and then review the script while that runs. All right, so the first thing that we do is create our main method. In our main method, we call the function byItem. Now, byItem is responsible for logging in as the user and then adding the jacket item to the cart. And then from there, it alternates between adding the 2 coupons. And the last thing it does is it checks if we get the congratulations message after we check out the item. And I'm noticing right now that we never actually purchased the item. And so first of all, let's view word wrap. We're definitely missing the last request in the application, which is checking out or purchasing the item. So for that, we're going to do checkout URL. It's a good thing we caught it before running the program. So that would be URL plus the request to check out an item, which is this one right over here. Let's copy that. And to do that, it takes in the CSRF token, and so we need to extract that again. But the nice part is that we already implemented a function that does that for us. So CSRF token, and that's equal to get CSRF token. It takes in the session object and then the cart URL. And then we need to add that to a variable called data checkout. So it takes in the CSRF token and nothing else. And the CSRF token value is what's saved in CSRF token. And then from there, we just perform the request. R is equal to s.post checkout URL data is equal to data checkout. Verify is equal to false, and proxies is equal to proxies, and this looks good. So this should be the last missing item. Now, if the response to this contains the congratulations message, then we successfully exploited the vulnerability. Otherwise, something is wrong with our script and we couldn't exploit it. So let's click on terminal, new terminal, and then run the application. So business logic flaw 04. And copy the URL of the application. Hit enter, and hopefully we don't have any errors. So if we go to burp right over here, we should see the requests that are being made. And it does not look like it's making any requests, which is quite weird. Let's see if we set burp configuration correctly. So HTTP, that looks good. I might have just copied it incorrectly. So let's hit send. That's still running fine. So something is wrong with my script. Let's end it and rerun it again. And try and identify what's breaking the script. Okay, here we go. So this should be HTTP, not HTTPS, because burp is running on HTTP localhost port 8080, and that's why you can't reach it. So let's end this, and now it should work. Hit enter. Here we go. If you look at burp, you could see that it's alternating between the different coupons, and then hopefully it should say that we successfully exploited the vulnerability. And here we go. It says we successfully exploited the vulnerability, and if we go back to the application, you could see that we got the message, congratulations, you solved the lab. All right, so we successfully completed the exercise by exploiting the vulnerability manually and then scripting it in Python. In the next lab, we'll look at a more complex case of a business logic vulnerability.